Okay. Last week with the locus. So our last week locus 1 was about direct interpretation of arguments and modulus. That is the quite basic ones. But today we will do more algebraically related locus. Okay? It can be any type of it. So as I told you before, in argument mode 1, most of the cases are more conceptual solving. So you approach conceptually, but occasionally, if you are really stuck, for example, as we did argument z equals 2 argument z minus 1, like this, then it's a bit hard to interpret conceptually, isn't it? If someone has a brilliant idea, then they can do, but it's a bit difficult. So if you're stuck and unable to directly interpret the locus, what's your next step? If you're stuck, so for example, another example is, okay, say this is a modulus related one. For example, this. Then if you interpret it, so modulus means distance. So distance from 1. This distance from, let's change it to I. Distance from 1 is the same as distance from I is here. So we are interested in finding all the points which is in equal distance from this and this. Then obviously the midpoint will be involved, and then we can easily think of that one. So it's direct interpretation. You don't need an algebra. Okay? And in an exam, they'll accept it. But imagine that it is really more complicated, and then you are unable to find the direct relationship. Then what you do, Hyun? So assume that you can't think of this. Then what's your choice?
Solve it?
Yeah, you solve it algebraically. That's the time you have to go to algebraically. Then if you're stuck, just interpret everything in algebraically. So this one algebraically is the modulus, isn't it? And what is the modulus of it? X minus 1 square plus y square. And square root. That's by definition, algebraical definition, isn't it? And then it will be square root y x square, because you are let x plus yi, and plus y minus 1 square. Okay? Then it becomes totally algebraical. Then you cut out. Then if you expand it, what do you get? X square is gone, x square is gone, y square gone, y square gone. And you're left with minus 2x plus 1 equals minus 2y plus 1, isn't it? Okay? Then if you cancel out, then x becomes y. Then that's exactly the same as what we expected. Perpendicular bisect. That is y equals x, isn't it? Okay? That's an algebraical approach. Okay? At the moment, I won't go any more exceptional variety of different cases. We'll do soon. You don't have any notes? You need any notes?
Do I do it in my school book?
You can have your. It's up to you.
Oh, it's very good.
Yeah. Then okay, let's do just once. I'll give you one simple question. Then this one you have a go by yourself. It's algebraically. All right. So have a go with this one. I'll give one notebook. Don't worry. Z minus 5, 2. Okay, think about it. So, yeah, have a go. Try this. Okay. in this case, again, our interpretation will be the distance from 2 is twice of distance from the 5. So then, actually, we did a similar question last week. So we have 2 here and 5 here. So the point is close to 5 or 2? To 5, isn't it? Because there is a twice of that distance. So 2 to 1. So there must be 1 point will be here, isn't it? And then if you go there, the ratio becomes less than 1 and 2, isn't it? So you have to bend in some way. So something like circle. That's what you know. So if you review it, any cases, a certain distance from a certain point is twice or 3 times, multiple of certain distance, that's always circle. Right? But in this case, if you draw just by mentally drawing it, the school won't accept it. Because that's not directly interpreted. It's hard to directly interpret. So in this case, you have to do algebraically. Then if you do it algebraically, again, then x minus 2 square plus y square root will be 4 because squared, and x minus 5 square plus y square. And if you expand it, you'll have x square, 4x squared, isn't it? Sorry. It's 2. Yeah. After you squaring, it's going to be 4. So after 4, if you expand it, what you have here, it will be x squared minus 4x plus 4 plus y squared equals 4x squared minus 10, 20, 40, x plus 25, so 100 plus 4y squared. Then all the terms moving into that side, then 0 equals 3x squared minus 36x plus 3y squared, then constant wise we have 100, and it will be plus 96. And if you divide by 3 on each side, divide by 3 on each side, it will be x squared minus 12x plus y squared. Something wrong, isn't it? Is that 32? 25 square 100. 4. Oh, should be right. Minus x equals 0. 32? Sure? Guarantee? Okay, 32. 32? Yeah. So I haven't divided, isn't it?
Yeah.
so it's too big. So if you 96. 6 square plus 36, isn't it? Plus 36. And y square. So you have only 32, but you use the 36, so you borrow the 4. So it becomes circle. Center there. So that means circle with radius of 2 and center equals 6,0. That's what we expected from there, isn't it? Okay, that's the algebraic one. Those are easy ones, right? Now, so those things are we like to do today for Locus algebra. Okay, so I introduce. Okay.
Luckily, I read the notation here. Like modulus of z minus 2.
Yeah. Okay. So what it is? Modulus of z minus 2.
Yeah.
Z equals y x plus yi, isn't it?
Yeah.
Then we collect real parts together, imaginary parts together, because we are interested in the modulus means the total distance, isn't it? The Pythagoras theorem. So we have to collect all the real parts. Real is x minus 2. Yeah. And plus yi. Then that's x plus minus 2 is y. Okay? So algebra 1, Okay. Find the locus if of z, if z what is it? Z plus I, z plus I divided by z plus 2 is okay, purely imaginary. Okay. One thing you need to be very clear. So when certain number is purely imaginary, okay, so there is something that equals plus I. Okay? And of course, triangle and star are real. If it is purely imaginary, what are the conditions to be purely imaginary? Triangle equals 0. Anything else? Star shouldn't be 0. Isn't it? If that's 0 and that's 0, it becomes real again. So imaginary part shouldn't be real, 0. So, okay? So this is the condition to solve that. So because what it asking is, it is purely imaginary. So we sort out rearrange it as real plus imaginary, and then let real part equal 0 and imaginary part is not 0. Okay? What about if it's purely real? Then just star equal 0. What about triangle? Doesn't matter. So that's difference, okay? Be careful. This is the question, very common, but many texts, even the textbook has wrong answers. Okay, let's go. So to try to find purely imaginary, we need to find out what is the real part. So that means we have to reorganize as real plus imaginary. What's the best way to rearrange it? Rationalization, isn't it? So to rationalization, so you have to again put that's z plus 2 and x plus yi plus I. Okay? So from the beginning, we clearly separate between real and imaginary. X plus 2. Okay, so if I summarize it, number 1, real equals 0. Number 2, imaginary should not be 0. Okay, if you are really brilliant students like Eugene, you already realized there should be another condition. What will be another condition? There's another one. What about denominator? Huh? Denominator shouldn't be 0, isn't it? It's automatic. Because already it is a fraction. So whatever the condition, eventually, okay, later on, eventually will end up with plus I like that. Okay? So you organize the rationalization of denominator, blah, blah, blah. Then definitely we have this one. When you say real equals 0, definitely you will say this is 0. And when you say this is not 0, you say this is not 0. But you never considered about the bottom, isn't it? So this is 0 is nothing related to this one. It is an independent condition that denominator must be defined. Okay, remember that. But we will see as an example here. That's yi. Now look, then x plus y plus 1i, and you trying to rationalize it. Then x plus 2, you multiplying conjugate, x plus 2 minus yi. Okay? Then, don't worry about the denominator because now it's totally real. So x plus 2 squared plus y squared. And if you expand it, we are interested in the real part. So real part, how would you get real part? X times that one, isn't it? X plus 2. You know. Where else can you get the real part? So imaginary times imaginary, isn't it? So it's a minus there, I is minus, so it's positive. And so plus y plus 1 times y. That's the real part. Plus I, imaginary part. Imaginary will be that product, y plus 1, x plus 2. Then that one, isn't it? Minus xy. Now we separate the component. So, to be purely imaginary, it shouldn't be 0, isn't it? That's the condition. That's the condition. So, if you expand it, what do you get? X squared plus 2x plus y squared plus y. It is real. It shouldn't be. It should be 0. Harry, what is it? What does it stand for? Circle, isn't it? So that means simply, of course there are other conditions, but if you just interpret that one, it will make a certain circle, and easy way is it goes origin, isn't it? It goes to origin because 0, 0, 0, 0. So there is some circle there. Any imaginary point on those circle, if you pick that any number from here and put that in here, then that total calculation, the result will have real part equal 0. Okay? That's what it says. Correct? Yeah? We borrowed 1, we borrowed 1/4, so we borrowed 5/4. So we did a plus 1/4 to make a perfect square. So we added a 5/4. Yeah, that's this. And what's the other condition? We have another condition here, which is if you expand it, xy is gone. Then x plus 2y plus 2, isn't it? So x plus 2y plus 2. That's the imaginary part shouldn't be 0. That's 1, 2, 3. Then another condition comes. Denominator, isn't it? Denominator shouldn't be 0. In what case denominator becomes 0? Yeah, and x equals minus 2 and y equals 0. So the z should not be 2, 0, isn't it? So which is 2, commit 2. So our final answer is, okay, to satisfy that one, the complex number it should be on the circle, but except those cases and those cases. So let's see what are they. So draw it. Then center will be 1.5 center. And what's the radius? Yeah, but we already know it goes center, so it's easy to draw. Something like this, right? So that will be half and 1. Radius will be. Okay. That's the solution.
Isn't it minus 1 also?
Huh? Where is it?
Isn't it just the sentence at minus 1 times half?
Yes. So a little bit like that. 1. So if it's 1, what's here? Minus 1, and there will be minus 2, isn't it? Minus 2. And also, this one is minus 2, isn't it? Yeah, minus 2. So it is solution, but clearly it says it shouldn't be this, isn't it? So if we, when z equals minus 2 comma minus 2, that will be 0, and everything will be 0, isn't it? So that means we have to remove it. Yeah, another condition here. X plus 2y equals 2. So y equals half x minus 1, is it? Okay, and let's draw. So minus 1 is intercept, and so there will be, that line will be here. Okay, so but that z shouldn't be on that line. So there is another one there. Where is it? We can calculate. It's a bit hard. It's algebraic a little bit involved, but simple calculations. So the circle will give you what you wanted, but except these 2 points. Okay, that's part 1. Part 2. What about this is a purely real? If it is purely real, and number 1, not on the circle, not on the, shouldn't be on this circle, isn't it? And so if you draw it again, so it's something like that. It should be on the circle, isn't it? And it should be, what's the equation? It should be equal to 0, so that will be the main thing. X plus 2y plus 2 equals 0. So y equals minus half minus 2 plus 1 equals 1. Minus 2 equals 0. Minus 2 equals 0. So our main solution will be this, isn't it? The solution, but not on the circle. So again, it's gone. So I'm not saying this is a solution, just for reference. And also it shouldn't be this again. So in this case, our solution is from here up to here. Okay? Any questions so far? Locus is a very, very important topic because it's usually like high mark question. Number 2, many students struggle with it. And on top of that, many, even good students, they make a lot of mistake. Why they make mistake? There are always exceptional cases involved. Exceptional cases. I told you when last term when you're doing the locus, the parametric equation, I told you that locus will be come again and again and again. So that's the first time come back again. Okay, there's another type of locus question. It is okay. So everyone knows what the definition of locus, don't you? So locus means if there are certain conditions involved with a certain variable, then what is the trace of the variable? So in this case, what it says is, okay, we'd like to know how W behaves if W is z minus 2 But Z is not a random number. It only moves around circle of radius 3, center to the origin. Then in this case, what do you think? Can you get a very easy solution? So what it is, so Z is this, that's Z, isn't it? So if Z is moving around, where will be the corresponding W point, which is Z minus 2? Sure, that side? Okay, if Z is here, where is the corresponding W? If Z is here, well, what about Z here? Say it's minus 3. Then what's the W? Minus 5, isn't it? Yes, here. So because it is not shift, it's just subtraction, isn't it? So all the values will be over that side. So the W will be something like this. Make sense, isn't it? Because all subtracted 2, just all move back. Right? But don't worry about the function. It's very elementary math. You subtract it, everything is back up. So cut down. So if it was 5, you cut back, cut by 2, then it will be back to 3. Fortunately, this is easy. Okay? This is easy. But what about it is a little bit more complicated, such as you can't imagine anymore, isn't it? Because it's so complicated. So you have to use more algebraical method. We'll get back to this. Now, in that type of question, if you don't get this idea that I'm going to explain to you, it's almost impossible to find the answer. But you know what's going on, isn't it? So if Z is something number moving around, as you start from 2, blah, 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 or it's a 2 is 0, 2 is 1, 2 is 3. If you move around, if you substitute that number onto here, then what will be the answer for that one? And if you put the numbers on there, that replace the number plane, what is the final shape? That's the question, isn't it? But obviously, you can't sub it in all the numbers. And even if you do the 1,000 numbers, you don't get any mark because there's no mathematical proof. Then what do you think, Eugene? How would you do? At the beginning, the idea of beginning is not mathematical. It's some common sense. How would you approach it? How would you approach it? If you just tell you the answer, you won't remember. How would you approach it, Harry?
Work out where W is in relation to Z.
So this is a relationship. This is only one condition you have. So we have to apply that condition to there, isn't it? But how can you apply that condition then?
Subit it.
How can you sub it in? Actually, his answer is right. You have to sub it in. Yeah, what else can you do? I'm seriously. Yeah, this is a condition that you have to use it. So you have to sub it in. How can you sub it in?
If we change Z into x plus iy, and then if we realize the denominator,
70%. Eugene, what do you think? So, yeah, Eugene? So, what Hen is saying is very close because you are saying that. So, what Hen is saying is x squared plus y squared equals 4. So, you rearrange it some way that you can sub it in there, isn't it? Or like modify the form, proper form to sub it in easily. I won't do it that way, but the idea is the same as mine. What I like to do is, why don't you, the easiest way you can sub it in will be rearrange it into Z equals W. What do you think? If the equation, if you rearrange it as z equals something, then what can be easier than this to solve it in z equals 2? Then once you get there, just do it. It's 2. Then forget about this. Then take the locus again. Okay? Remember. Okay. So our general rule is if one variable has a strict condition, another variable is just function of it, then rearrange the way to directly solve it in the given condition. Now, so rearrange it. So that means you have to collect, disintegrate to find all the z factors and factorize for the z. So collecting all the z terms. So w 1 minus z equals z minus 2i. Okay, we collect for z. Collect for z. Where is z? So minus w, and there will be minus 1 as usual. Then minus, what's this? Minus 2i. Then what you have here, it will be, what do you left with? Minus w, isn't it? Right? Then z becomes minus w, minus 1, minus 2i, minus w. Then solve it in. The reason I specifically selected that question is because there are some other algebras that you should know. Okay? I'll leave it there. Okay? We'll back to it. Okay? If you do the exactly same method on here, how would you do? Make it z equals something. And z equals w minus 2. Then apply it. So what's the locus for z? Okay, I think if you remember, this is a standard one, right? Yeah, the center is 2. So the w is all the complex numbers, which is 3 unit distance from 2. That's a standard one, so, because we just missed in last lesson. So from 2, all the points which are in the 3. Yes, that is a circle. It's plus, isn't it? Plus. So this is different from what I expect. Okay? And then, just for those who haven't done it or forget it, why does it become a circle? So interpretation-wise, always when you interpret modulus, always interpret distance from that one, distance from minus 2. Okay? Which is 3. That's a circle. Okay? That's what I recommend. And in this case, if you also forgot, then also you go back to the, when you start again, go to the definition, algebra. Then what is this? Square root x plus 2, because it's x plus yi, plus y, y, so square, it will be 3. Go away, square. That's circle again, isn't it? Okay, but this is something you can directly answer in this. You don't need to do it in the exam. So you can see absolute value equals 3, you can say it straight away. A circle with a radius of 3. Now, so that's the easy part. So it just came here. So again, this is 2. Now, okay, so we came up to here. Now, almost there, but you have to simplify it, isn't it? How would you simplify it? Okay, from here on, everyone tell me one thing you can do to simplify it. Realize? I wouldn't. Making difficult. No? Not Jihun, isn't it?
Oh, no.
What's your name?
Shihun.
Not Shihun. Yeah, Shihun. What's your idea? Anything you can do?
Times W bar minus 1.
So it's minus 1?
Times minus 1.
So kind of personalization of kind of things. Yeah. Okay. What about Eugene? Anything? Do you remember? I told you I pick up that question because I guess that's gonna happen. From now here, we will learn many different techniques involved with the modulus. As you know, the modulus, which is absolute value, kind of, you don't have any algebra, isn't it? But there are few algebras we can do. Okay, number one. So minus minus. Would you be worried about minus? Can you change it to plus? Yes, because minus you don't care. You don't need it. Right? Again, I'm still again emphasizing, memorize those techniques I'm telling you. Because this is very, very useful formulas, like techniques to handle with the modulus. Then how? So if we have only one W, that's easy, isn't it? But there are two W. What can you do? Can you do it this way? Can you? Yes. Okay. Absolute value, you can separate it, right? Modulus, because that's important one, very important one. One of the hardest question in complex number algebra is proving inequalities. Proving inequalities. Okay? But when you prove it, the harder questions are always about the modulus proof. There are typical 2 or 3 questions. On exam, students always fail to prove it. But only those who know how to deal with modulus, they can prove it. We'll do it today. Okay, so remember, there's another technique, isn't it? Okay? You can separate it. Then, of course, you can swap it. Happy? Then this is what you learned already, isn't it? Standard form. What does it say? What does it say? W, usually it's omega. Omega is a complex number, which is located in a way, the distance from 2i is twice distance from minus 2i and minus 1. So from here to there, about here, 2 to 1, something there. Then as you know, remember we did, if your distance from one point is certain times the difference from the other, what is the solution? Circle. So probably circle something like this. Now how do you find the exact circle? Algebra. Then there's a time you can say let W equals x plus y. And in this case, x plus y plus 2i equals twice of x plus 1. Once you can use it, you don't wanna do these steps, you just jump it straight. So x squared plus y plus 2 squared square root is twice of x plus 1 squared plus y squared. That's it, isn't it? Remember that formulas. Find the locus of, in exam, they might ask exactly the same thing, but they might ask in 2 different ways. So, example, find the locus of z plus 2z minus I. What? 2. If Don't worry about this. In this case, it's not. There's only one way. Okay, so we define new. Let me check. Sorry, the question is that if so Z, we like to know the locus of Z, but Z has a strange property, which is if you rewrite it. And if you calculate that value and calculate the argument, then the argument is pi on 3. In what case, of course, there's a certain restriction, isn't it? Z can't be any number. It can't be any random number. It should be a certain number. Then, surely in this case, we can't use the method we used there, isn't it? Because we are not interested in not W or something, or this one, you can't really directly sub it in, isn't it? So usually the one that I used here is when the given condition is something that is 2, then it's rearrange it. But in this case, by rearranging it, what can you do? You can't do anything. If it's argument, to calculate the argument, what do you need? Huh? Louder.
Imaginary number.
Yeah, to calculate the argument, if a certain number's argument is 3, like pi on 3, you should know what? You need to know x, the real part and imaginary part, independently, so that you can calculate, isn't it? Can you get the idea? So what do you need to do? You have to separate real and imaginary from this part. So what they're saying is, if you change it to real plus imaginary I, then the angle made from here is a 60. That's the condition, isn't it? So the argument, you should know x and y, the real and imaginary. So you have to sort out. So to sort out imaginary and real, what do you have to do? You have to put x plus yi first, and then rationalization, isn't it? And then by following some trivial conditions. Number one, can't be 0, the denominator can't be 0, or blah, blah. Okay, let's do that. So I'll give you 1 minute, have a go. So what I'm saying is, let z equals x plus y, and sub it in, and you separate between real and imaginary number. that square plus square is product of conjugate. So you like to do something, you stuck, you have to change it to something. What do you have to do? Square each side. Okay? Anyway, though both are positive numbers, square does not destroy the direction of inequality. So square both sides. And for technical purpose, when you compare the inequality, one easy way is subtracting each other. Then calculus become a lot easier. So our aim is left square minus right square. Okay. Left square will be z plus square minus left square will be okay. And you will see if it's positive or negative. Okay, now time to you can expand this one, x square plus y square. And you expand it, what do you get? Z square? Sorry. Sorry. You can't do that, isn't it? So what can you do? See? You can change it to that. When you're doing that, you already guess. You can do that, isn't it? The conjugate always you can separate it without any conditions. Doesn't matter if it's a plus, minus, division, or multiplication, whatever, square root, power, always you can separate it without any condition, without affecting inside. When you expand it, what do you expect? You'll get z times z bar, which is that square. Okay, so that means you should know both sides, isn't it? That one and x square, y square. And minus, that will be z square plus 2z w plus. Okay. And you expand it. If you expand it, minus is it done? Then gone. It's gone. 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 Then we have to compare, huh? Who is bigger? This one definitely bigger, isn't it? But how do you know? There's another important algebra you should know. What are the relationship? What are the relationship? Correct? Isn't it? Okay? So actually these two are conjugate each other. There's another point, right? Another point. Because when you expand it, if you expand it, it becomes, it's cancelled out. So you can expand it, right? So that's another thing you have to remember. If you don't know it, you can't detect it. Okay? Anything is alternating, they are conjugate each other. Now, can you do that? Yeah, Hyun? Can you change it to that? Yes. Absolute value, a product. You did it before, isn't it? product or division, always you can separate it. See, there's a lot of algebra involved, isn't it? If you're not explaining, if you don't do it, you're never going to know it. But once you know it, it's a very useful method. Okay. Now, you adding two conjugate numbers, conjugate pairs. What's the answer? It is 2 real, isn't it? 2 real. So it is 2 real of, okay, minus 2. Okay, that's another point again. It keeps coming. Very important algebra. Another one coming. Automatically, when you see 2 conjugate pairs added, it's 2 real. If they are subtracted, 2 imaginary times I, because I survives. Okay? So Z plus, easy to say here, but in this case, you should need to be able to pick that up. The 2 real. It must be automatic, imaginary times I survives, because the imaginary doesn't give I. Then, what's next? We have to show something. It looks like, but you can't really say. You can't explain. So there's another point to it. Look at this. Say. What's the size difference between conjugate pairs? They're saying, So even here, where is it? Even here, you can change it if you want. Doesn't matter. Okay? So in absolute value, if you conjugate, you can add it, subtract it as you want. Then, now it's clear, isn't it? It is so real minus modulus of a conjugate number. Which one's bigger? That's definitely bigger, isn't it? Definitely bigger or equal. When is it equal? Yeah, it is equal if its argument is equal to 0. In what case argument equal to 0? It is a certain condition. Maybe same as this one. Yeah, think about it. Okay, so can you see there are very important algebras are all involved. That's why I'm introducing that one. Okay. So you should know, practice many times, right? Not because that question, because the involved algebra is very important. You won't learn anywhere as a concentrated form how to deal with the modulus. That tells you everything. That's all about. Okay. But again, a common exam question, very common. Do you think who's gonna solve it? Yeah, then many things go up to around here because they saw somewhere, but the detail they can follow. So, sleepy? Is it because you are tired? Because it's quite boring. It's too easy. Okay, for your, just because time's almost up, so you can't do any. So I'll just pick it up, mating up one question. Just practicing. Okay, Harry, I'm sure you can solve it in 10 seconds. You need to be able to. Okay? Even 5 seconds. So that means There's a quick way without algebra.
Minus 90.
That's too expensive. Any discount? What's the modulus for top? Minus 45. What's the bottom? Plus 45. So what's total? Minus 90. What's the size? 1. So 1 and 1, isn't it? So 1 and 1. What's the angle? Half of it. So minus 45. What I'm saying is, that's a very important concept when you do. You have one complex number and another complex number, but same size, then what's the argument if you add them? Average. One complex number here and one complex number here, but if size are same, when you draw the addition, it actually halves exactly, isn't it? Can you get that idea? So as soon as your point that you should know is when you look at it, you quickly calculate what's the size. It looks like very tedious, but in exam, many cases, usually fraction, more than 70% cases, I guess, always comes in unit. The top and bottom are exactly the same size. Typically. And 1 minus I, 1 plus I is most commonly occurring. Because they're not asking you calculations. They're asking more easy calculation concept. So you need to pick that up quickly. But everyone get that idea? If two complex numbers are same size, then arguments are average. So in this case, size is 1. What's the angle? Minus 45. Minus 45, so it's minus 90. So average 45. It's minus 45. Okay? Question?
How does it get to minus 45?
This one?
Yeah.
Okay. Do you get that is minus 90, isn't it?
Yeah.
Yes. So if you calculate it, it will be 1 plus C is minus 90, isn't it?
Yeah.
Yeah. And what I'm saying here is if you have 1 here and adding it, say is in generalized to theta. Okay, we're adding 6 theta. Then actual total argument will be this. Because they are same, that angle will be half of this. Because this is theta, the same size, there is half theta, half theta. But it is important as geometrically, but more important one is you need to be able to pick it up. Two complex numbers are added up, but they are making modulus are same, then argument is half of it. Sounds very unusual, tricky one, but very commonly occurring one. But if you don't know it, you wouldn't know it's very common. Once you know it, you realize it's very common, very useful formula. Do you remember that? Probably second lecture, we did 1 plus c theta. Do you remember that? When you simplify it, how do you simplify it? 1 plus cos theta plus I sine theta. And then use the half angle formula for that. That will be 2 cosine square theta plus 2I sine half theta cosine half theta. And 2 cosine half theta is common. And then it becomes half theta. That's why I told you that this is one of the very typical basic. Same idea, isn't it? Same. 1 plus c theta. Same 1 c theta. If you add them together, it will be that one. What about the size? Then it's a half theta. Size will be cos half theta, twice of it. Cos half theta, twice of it. And angle is half theta. That's something basic pattern you should know. Then once you realize that and you practice it, it becomes the same idea. Okay? So it's quite detailed and in-depth, but something you have to memorize and familiarize. If I go back to the first statement I gave you, complex number will be a lot easier. You will be able to see as a geometrical pattern rather than calculations. Okay? If you rely on calculation, there are so many questions you can't even touch it. But once you interpret as conceptual picture, as geometrically, it becomes very straightforward. And then you do add your algebraic technique. In these cases, of course, there is something you should know. But if you are able to interpret geometrically, it becomes very obvious. So everyone understand how I get very quickly? And in the exam, you already, so if it is in the exam, quite likely question 1 is in it. Because everyone can do it, but matter of how accurate, how fast. But once you read the R, this is minus I, isn't it? Then it's the end of story. So you already know the answer. How can you make a mistake? And you'll very confidently say it's 1 plus I, or so you're just pretending to something. Minus I, plus I. You just pretend to say, and it's I. And 1 plus I. That you know. And even if they ask me to find it as a polar form, cis form, and even sometimes just write it, it's I and 1, so it will be root 2 in 45 degrees. You can draw it, and they'll accept it. You don't need to show you the tangent, inverse, blah, blah. You don't need to do that. Okay, if you're competent geometry, then you can say, oh, root 2 cis. It's minus, so it's minus 45. Okay, we'll finish here. In your school, where are you up to?
You're not doing it in order, you're doing it when.
So what topics have you done? Is there any topics that we haven't done? So we are far in advance? Same to you? I'm sure same to you. I'm sure same to you. But in the school, what topics have you done?
You just started.
You just started. Just started. So, okay. Next week, we'll do the unit complex number. Then in complex number, there are 2 categories. One is so-called complex number. Next one is complex number, but in application to polynomials. Some schools consider it as polynomial and they learn from polynomial part. Some schools they do at once when they do complex numbers. But I'll see how your school going. So once you finish the unit complex number, you are very much up to there. Okay? Then we'll do more past papers and exam preparation, and then wait and see if your school touching this one or not. Then once they touching it, then you quickly do it. Okay? Again, as last week I told you, it's time to what? What you have to do now? Yeah. Yeah, 4 hours. 1 hour study with me, you do 4 hours. Yes. But at home, what do you study? All the past paper solutions are already in the internet. Watch it. Okay? And anything you're not sure, what do you have to do? Ask Victor. Okay? We'll organize one-day sessions again. Ask Victor. Okay? Or even ask me. Now, once your process finished, I give random question answering. If you don't have any questions, you go to some other things. Okay? So anything you. I'm not just asking just individual questions. Anything you are conceptually unclear, ask me. Okay? And then regularly study the past papers in the internet. Okay? There are all HS papers, Catholic papers, James Ross papers, all solutions there. Okay? That's done last few years. Exactly the same whiteboard. Okay, we have a